Okay, so I'm going to demonstrate how I crop the ROIs for four categorical selective regions. So we have fusiform face area and occipital face area for face, parahippocampal area for scene, extrastriate body area for body parts, posterior fusiform and lateral occipital for tool. So let's start off with FFA, bilateral FFA for one subject. So to do that, we go to MATLAB and then go to the subject directory where the contrast files for each category versus other categories is stored, and then open up SPM. And then we click results here. Click spm.mat, done. For face, we use a contrast face versus scene, which is shown to be the most effective, or maybe not most effective, but one of the very effective contrasts for localizing FFA. Apply masking, none. P-value, I typically set it to be 0.01 as default. And let's set it to filter out all the voxels below 10. And then we get this contrast for this cluster map for the contrast. And then we want to view this on the subject's T1 map. So we go to overlay and then sections. The subject's T1 map is stored in a separate directory under fMRI, and go to the subject's folder 944, and it's stored in this ANAT folder. And we pull this one with the warped out and then done. So here we have that subject's T1 map. And then we first localize the right FFA. So we go to the right temporal lobe, and my experience, the FFA is towards this cluster. It's posterior and on the temporal lobe with a negative Z value for the coordinates. And the range for the X coordinate is typically between 30 to 50. And to pick out the most significant voxel, we go to nearest local maximum using the right mouse click. And then this is the cluster where I think the right FFA is at. And then we go to this current cluster, click on there, and there we go. We have this cluster with this peak coordinate, and then this KE is how many voxels there are for this cluster, and we record it on the Excel sheet. So we type in the coordinates, and then volume 182, 1.01 uncorrected, T-stat. So we're pretty confident about this right FFA. So the subject happens to have a very clear FFA. And then we go to the left-hand side, which has the similar y-axis, y-coordinate value. Go to the nearest maximum and click on current cluster. So here we see the voxel size is very large. It's larger than our volume range for FFA. So what we could do to set it to be a smaller volume is we could set the significance level to be more strict. So let's change it to 0.05 family-wise error rate. You could change it to other values if you want, a smaller value uncorrected. And family-wise error rate is obviously more stringent criteria. So let's try this first. Okay. So as you can see, the volume size has decreased a lot, which is what we want. And then we record it. So 0.05 family-wise error rate, t-stat 9.31. Okay, and then just want to view it again to make sure it's on the right part of the brain. Okay, so how do we crop this ROI out? We go to MATLAB and open up Marsbar, which is a program or interface designed for ROI cropping. Under this menu, go to get SPM cluster, and then you will see write ROIs here. So we go to write one cluster, and then it would automatically just select the cluster that we set it the coordinates to be, and then label for ROI. So here is very important. You set the label to be FFA dash left hand. According to what I've written here, we want the namings to be very consistent, exactly the same for all subjects. Or when we load it up on the script, it would give us an error. Okay, enter, and then the file name would automatically have an dash underscore ROI.mat. So we save it. And since I forgot to crop out the right hand FFA, and it has a different significance level, we set it back to be 0.001. Okay, and the coordinates for the FA right hand side is just put on the Excel sheet. Okay, so that's the cluster, and then go to Marsbar again, select SPM cluster, write one cluster, and this label would be FFA dash right hand. Enter, save. Great. So that is for FFA. You could view it left and right together. Yeah, that seems to be the right part of the brain that has FFA. And as you could see, they are on the same y-axis, more or less. So that is a good sign. And now we move on to OFA. Okay. So we go back to the SPM. Since we opened up the Marsbar, we need to load the SPM.mat again. Face versus scene. So OFA is more posterior to FFA. Overlay it with the subject T1 again. Start off with the right hand side. So typically OFA is directly at the back of the FFA, towards the very back part of the brain. So here is a graph of location for the OFA. It's directly towards the back of FFA on the occipital lobe and towards the ventral part of the brain. So this cluster, well, I'm not sure if it's a localization problem for this subject or if it's really the cerebellum. But this doesn't seem to be the OFA. Yeah, it's too ventral. So what we could do is click around the brain and then find another cluster Oops, the internet is obviously not very good. So this brain turns out to be a bit abstract now. Let me start off this session again. Okay, let me just wait until this server gets clear again. So let me pause the video for now. Okay, so the screen is back up. Let's do this again. We're finding the right OFA, but it seems like this cluster is too ventral for it. So we move up a little bit and then see if this could be the OFA. Okay, so in my experience, the OFA is even more posterior and close to the very back of the brain. So this one seems a bit more lateral than what I think, but it seems like the most possible OFA, right? So let's just record it and make a note that we're not really confident about this. Okay, so OFA right-hand side, coordinates, and then let's see how large is this. Okay, so this cluster seems a bit too big than what we want it to be. So let's lower the threshold. Okay, now it's a much more reduced. Instead, it's 7.65. Okay, so let's make a note, questionable, a bit too lateral. When we do the analysis for reactivation, if this OFA shows less of a significant value, then we would know like a potential factor could be that it might not be the exact region for OFA, that this subject might just not have a very pronounced OFA for this task. Yeah, OFA effect for the task. And then for the OFA right-hand side, let's go back to the brain again, somehow this, not sure if it's the internet or something, it's abstract again. Local maximum, and this seems like symmetrical cluster. Okay, so when we click the current cluster, this cluster is embedded within a larger cluster network. So you could see there are 3 clusters, subclusters within this big cluster. And this big cluster obviously has a even a larger volume. So let's set the significance level to be 0.01 WE. Okay, the volume has reduced, so that's good. And when this is the case, when we have like multiple subclusters within a network, what I typically do is first I record coordinates, and then for the volume, I don't input anything for now. And then this is 0.01 and T-step. Okay, and then go to Marsbar. We first save this large network of clusters. label would be OFA left-hand side. Make sure you label it correctly. And then we save. Okay, so I didn't save the one on the right-hand side. So let me do that first before I demonstrate how I deal with those 3 clusters in the network for the OFA left-hand side. So the significance level for the right-hand side is 0.05. Let's set it back to be that. Okay, great. This internet seems to be better now. And let's set the coordinate to be the one that we extracted. So that is the right cluster. And then crop it out. OFA right-hand side. Okay, great. Then we go to the Marsbar, click on view, and let's see the OFA left-hand side where there are 3 subclusters. So you see, right, it's not like a single big cluster, but there are like sparkle clusters over here. So what we typically do in this case, if we view it and find it to be a bit all over the place, we build a sphere around the peak that we just extracted for that ROI. And then we find the overlapping region between the sphere and the large networks of clusters. And then the overlap would be categorized as the ROI that we want. So we set a limit to filter out the other irrelevant regions or voxels and focus only on the peak. So let's set the sphere center to be minus 34 minus 74, 4. And I typically use 10 millimeters for this description, just a sphere at this peak, and save. And then we go to this drop bar and then transform, combine ROIs. So we want to combine OFA left-hand side, the sphere. Click those 2. Function to combine would be R1 and R2. So that's the function for finding the overlapping region. And let's set the label to be OFA dash left hand. And save. So it will say if you want to replace it with the old one, which has the 3 subclusters one. So we click yes. And then let's view it. Okay, so that's more defined than the one we had. And again, it doesn't seem like the OFA to me, but it's the best that I can do for this subject. So again, this note here is important. Yeah. So let's look at the right one. OFA right-hand side. This one seems fine. And let's view it together. Okay. So again, make a note of this OFA left-hand side as a bit too lateral. It might not be the OFA. Okay, so that is all the ROIs for this subject for the phase category. And then we'll move on to the scene category to see where PPA is located at. So typically PPA is very defined. It's the easiest ROI that we could crop among all the categories. It's really pronounced typically. Okay, let's come back to this later after I take a break. Okay, let's do the parahippocampal area. Go to results, click on SPM, and it would be the contrast called scene versus face. Again, that's shown to be a good contrast for the PPA localization. So p-value for this one, I typically first try a pretty low threshold. So let's try 10 to negative 8. Okay. And then we see the clusters for this contrast. And there we go. PPA is very clear on this subject. Click on current cluster. PPA is around 100 to 500 voxels. Let's make it a little bit bigger. I typically have it like around 300. Okay, maybe a little more. Oh, at 330. That's good. So let's record this cluster. Negative 30, negative 44, negative 6, 30 voxels, 0.001 FWE. And let's find the right PPA now. Just right across it. Right one seems even more than the left one with the same p-value. So let's see. Okay, so it has a lot of other voxels as well. Let's set to a stricter FWE. Since the volume is too large for that one. Okay. Even higher, means smaller. Okay, good. Let's record this cluster. And we could see that PPA right and left have roughly the same y MNI coordinates. Okay, 99 and 1 to the negative 6 FWE. Stats. Okay, let's extract this. Go to Marsbar, get SPM cluster, write one cluster. Label would be PPA. Right hand. Save it, and then I forgot to extract the other one. So let's change it back to 0.0001 FWE. It's 30 minus 44 minus 6. That's the left PPA we just found. PPA left. Okay, let's view those two together. On Marsbar, click the two PPA we just cropped out. And yay, here we go. Good. So PBA is typically the easiest ROI to crop again. Let's move on to body part. Click result, SPM.mat. We use body versus tool as a contrast for EBA. And I typically just set it to be 0.001 for this contrast. Let's see where EBA is at. Overlay, previous section. Okay, great. So this subject has very clear EBA. It seems like to the nearest local maximum. EBA is typically towards the dorsal part of the brain, so the Z and I coordinate is typically positive. So click up until we see Z around somewhere between, typically between like 10 to 20, definitely above 0. So here is an idea of where EBA is at. Yeah, so here we have the EBA. And you could refer to this article if you want to get a better sense of the localization. Okay, so let's crop this out then. First, do the right EBA. Click on current cluster. It's within the range of volume, so that's good. And for this, go back to the brain and click on the left EBA. The y-axis is typically pretty small for EBA, so it's negative with a large number here, typically around 70 to 80. Okay, we record this cluster. And we don't record the volume because it has a lot of other clusters and we need to overlay it with a sphere. In my experience, if this has too many subclusters, then it's good to crop it out with a sphere or it would be all over the place. So let's write ROI, write 1 ROI, EBA, left hand. Okay, and then again, crop out the other side. Let's view the EBA left hand. Okay, so you see there are other subclusters and that could be confounding. So let's make a sphere. Around the peak. Okay, and then transform, combine ROIs, EBA left hand, and the sphere that we just made. Make sure you click on the right sphere because there might be other spheres that we already made. R1 and R2, label EBA right hand. replace it, yes. Now we view it. Oh, okay. So here comes an error. We just named the EBA wrong. We named it to be EBA right hand, but turns out it should be EBA left hand. So here is indeed the EBA left hand that we want. Yeah, so let's change it back. Let's delete this. So this should be EBA EBA left hand ROI. Okay, so now we need to crop the EBA right hand again because we just lost it due to the naming error. So important lesson here, name it as it is. Sometimes when there are too many ROIs, it could be confusing with the manual work. It's okay, since we recorded the coordinates, we could always crop it out again. Let's input the right EBA coordinate. And then go to Marsbar, get the cluster, EBA right hand. Okay. So let's view the left EBA. And here we see that after overlaying with a sphere, it's no longer that sparse. And then we record the volume for this new EBA left hand to be 1160 divided by 8. So the voxel size is 2 times 2 times 2. And the voxel volume is 1160. So we divide it to get the number of voxels for the overlaid EBA. Yeah, so every time you overlay ROI with a sphere, you get the volume by doing the division. Okay. Okay. So here, let's make a note, masked with a sphere for the left EBA. All right, let's move on to the next category, tool. So watch carefully now because tool category is typically the most complicated one to deal with. Go to result, SPM.mat. For tool, we use tool versus baseline. So this one, I always set it to be a very low threshold in the first place because it has too many clusters if I set it to be a large p-value. Okay, let's view it on T1 map. First of all, we want to find the right-hand side posterior fusiform for the tool. So that would be on the temporal lobe. It is posterior, so it's on the back, and on the fusiform gyrus. So typically around here. Yeah, so it's right back to FFA. Therefore, the y coordinate is smaller than the FFA. So here we have FFA right hand, y coordinate minus 48. So for the posterior fusiform, it should be smaller than -48. Right hand click, go to nearest local maximum. So this one has y coordinate -58, which is smaller than -48, so that's good. This subject has a pretty round brain, so typically the fusiform y coordinate is around like -70 or something, but this subject tends to have a larger y coordinate. Click on current cluster. So again, it's embedded within this network of cluster, but let's first record it and then crop it out with the sphere. And we don't record the volume here because we're going to overlay it with the sphere. Significance level. And t-stats. Typically get a pretty high t-stats for the posterior fusiform and lateral occipital for the tool because it's so pronounced. Okay, let's crop it out with MRI. Marsbar. Right one cluster. Label is important. P-fuse. Right. Now let's crop the left fuse right across the hemisphere. Okay, this one seems a bit more anterior because the y coordinate is supposed to be again smaller than the FFA. So let's click back. Okay, it switches back to this. So let's see if within this cluster, if there are any other subclusters. There's a better choice. This one's got a positive z coordinate, which is not typically the case because P-fuse is supposed to have a negative z score. Z coordinate. So it's somewhere here, so it's back to the FFA. Okay, so let's click on the whole brain to see if there are other clusters with a negative value than this. See, FFA left hand is -52, so okay, since there aren't any, let's set the threshold to be higher. Let me just see where FFA for this subject is located at. That we already recorded. So here is our FFA. So posterior fusiform should be even more posterior than that. And it seems like this ventral stream is, for this subject, is not directly back, but like with a inclination here. So let's just click more posterior and then click up. Let's just use this for now, and then write a note that this one is a bit more dorsal than we think it should be at. Let's keep the significance level to be the same, as we are not picking up on the volume now. Okay, so on this note here, I write questionable diffuse right hand side, left hand side, a bit too dorsal. Okay, and then we crop this out. Write one cluster, label P fuse dash left hand side. Okay, so before we overlay those with sphere, let's take a look at LO. LO is typically dorsal, more dorsal to the P fuse, and then it has like a positive Z value here, and it's more posterior to the P fuse. So the Y coordinate here would be smaller than the P fuse. This subject has a pretty clear LO, left and right. Let's do the right one first. To nearest local maximum. So this seems like a the right coordinate. So it's lateral. You can see it's lateral, and then it's occipital. Click current cluster, and then we record it. Value is 16.12. Okay, and write this out first. LO with both capitalized letter dash right hand. Save. Okay. Let's look at the left LO. That's the cluster that we want. Minus 30, minus 80, and 16. That. Okay, so the more experience that you have, the faster this process would go. Write one cluster, LO, left hand. Okay, now let's first give you a sense of, before overlaying with a sphere, what those regions look like. So let's click on LO. See, since both LOs have multiple clusters within like one big cluster, it's pretty sparse here, right? And we don't want that. We only want the specific part of LO. We don't want this huge cluster that has all the subregions. So let's build spheres now. Build a sphere. Start off with right LO. The peak is 28 minus 88 and 20. Save the sphere and then build another sphere for the peak to right LO. minus 30, minus 80, 16. Okay. Now let's transform, combine our lines, LO right hand. Make sure you click on the right sphere. LO right hand. Save it and overlay it with the previous one. So you don't need the one with all the clusters anymore. Then we do LO left hand, the right sphere, minus 30. LO left hand. Okay. Now let's view LO right hand with the overlay. There we go. It's much better. More defined. So the volume would be 3176 times divide by 8. Okay. How about LO left? So that's 1992 divided by 8. There we go. So we've just finished overlaying the multiple clusters LO with a sphere to get a more defined LO. Now let's do the same thing for the p-fuse, which also has multiple clusters. So before we overlay with sphere, just want to give you a sense of before overlaying, it's a big cluster, even maybe the same with the LO, but you see here, that seems to be the LO, but we only want the part where p-fuse is at. So let's build a sphere. Center of the right tool, p-fuse, 36, minus 58, and minus 8. Okay. Then build another sphere. 38 minus 68 and 2. Okay. Now let's transform the right p-fuse. Click on p-fuse right hand side and the right sphere, which is 36. The more spheres that you have, the more careful you have to look, or you select the wrong sphere and it would not do the job. Okay, I just messed up the naming, so it's supposed to be right hand. Okay. Glad I caught that error, and then transform the left p-fuse. With the right sphere, 38 minus 68. I might have. Okay, so this is supposed to be minus 38 because it's the left hemisphere. So let's make another sphere that's correct. Minus 38, minus 68, and 2. Here we go. Left p-fuse and minus 38. R1 and R2, description, set it to be default, and then labeling would be pfuse left hand. Place it, yes. Let's view the right pfuse first. Okay, much better. That's the overlay between the sphere that we just made and the large cluster of right pfuse. Okay, how about the volume to the left pfuse? Okay, good. There we go. So that's how you make the 4 ROIs for a tool. And then for notes here, we want to make sure that we write mask with a sphere for all 4 ROIs. Okay, so this subject is almost done. Well, we sort of forget to record volume for this one. Let's view the left OFA. Okay, so pretty small. There we go. Okay, I guess the internet is slow again, but this is how you make ROIs for 4 category selective regions for each subject using Marsbar and SPM. It's a lot of manual work and a lot of judgments, but the process could go faster and with more precision, with more experience. So yeah, just to make sure that follow the steps and record every detail. If there are more than 1 clusters that you think could be for 1 ROI, for example, if we think there are 2 clusters you're indecisive about for the pfuse, then what I typically do is I have another row here and with a title, other candidates for ROI, and then I do the same work for that cluster. So I basically just crop out all the candidates I think could be possible, and then try those out for analysis later. So we don't want to miss any potential candidates because the brain is complicated, and it's good to make sure we include all the possibilities. Okay, so that's it. Have fun cropping ROIs, and excited to see how those play a role in the reactivation analysis.